Hello, my name is Keshwani. There's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase it immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 313. Please turn to it. Page number 313, and today is our lesson number 30. The very first problem deals with the parallelogram, and they are asking for the area of the parallelogram, number 38. Question number 38 says that we are given a parallelogram area of a parallelogram with vertices 0, 0, 10, 0, 13, 6, and 3, 6. Let's find out, shall we? Let's first draw the parallelogram. It will be easier for us to deal with it if we know what it looks like. Let's draw it, shall we? So we have one point here, 0, 0. Then we have 10, 0, 10, 0. Let's call it 5 and 10, 10, 0. Then we have 13, 6, 13, 6. This is 15, so 13 is going to be somewhere here. Let's say this is 6. 13, 6. And then we have 3, 6. So let's say 3 and 6 right here. There is our parallelogram. This is our parallelogram. Let's call it A, B, C, and D. We are interested in the area of this parallelogram. Well, what is a parallelogram? Seems like a very strange question, very simple question. A parallelogram is a quadrilateral, and any quadrilateral is simply what is a quadrilateral? A quadrilateral is so called because a quadrilateral is a four-sided picture. And what exactly is a quadrilateral when you're talking about the area of that picture? Well, if you're interested in finding the area of the quadrilateral, then it helps to realize that a quadrilateral is simply a union. It's a marriage of two triangles. It's a union of two triangles. And since we are talking about parallelogram, if we're talking about parallelogram or a square or a rectangle, these are very symmetric pictures. And since they are very symmetric, the two triangles that we're dealing with here, this triangle right here, this triangle right here, is the exact same triangle as this triangle right here. The areas are the same. It's a union of two triangles, as you can clearly see, two exact equal triangles. And how do you find the area of a triangle? Area of a triangle is simply area of a triangle, let's call it triangle ABD. Area of the triangle ABD is simply 1/2 base times height. 1/2 base. How much is the base from A to D? A to D, this was 10, 0. This one was 10, 0. A to D is 10. That's our base. How much is the height? What does height mean? What does it mean when you talk about height of a triangle? For example, if we're talking about a triangle something like this, what's the height of this triangle? Height of a triangle is exactly what it says. Height means how high is the highest point in the picture. One more time. A height of a triangle simply means what's the highest point. How high is the highest point in the triangle from the base? Here is our base. Here is our highest point. How high is this part? This is the height. This side is not the height. This side, let's call it A, B, C. B to C is not height. B to C is not the height. The height is from B to D. B to D. Height is equal to B to D. What's the height of this particular triangle? Well, the height is, let's put it here. the height of ABD is this guy right here, this distance right here. And how do you find that height? Well, that's simply the y-intercept, or rather the y-coordinates of point B, which was 3, 6, or this guy here, which was 13, 6. 13, 6. The height is 6 units. The height is 6 units. So that's the area of one triangle, ABD, triangle ABD. We have ABD and we have triangle BDC, and they are identical. Since we're looking for the area of the parallelogram, the area of the parallelogram is going to be this plus this. In other words, instead of taking half base times height, all we have to do is just take the base times height, and base times height will do the trick. Base times height equals the area of the parallelogram ABCD. And that's just 60. The base is 10 and the height is 6. That's all. It comes from base times height, which is because one triangle of the two symmetric triangle, one triangle is half, which is why it's half base times height. The reason why area of the triangle is 1/2 base times half, 1/2 base times height, the 1/2 part comes from the fact that a triangle, any given triangle, is only half of the other half is missing in the parallelogram or rectangle or whatever it is. Do you understand? Let's go to the next one, shall we? Number 39. Number 39. Number 39. For example here, let me give you a simple example. For example here, here's a triangle. The base is 5 and the height is, say, 7. How do we find the area of this particular triangle? It's 1/2 base, 1/2 base times height, which is 7. What I'm trying to make you understand is, why is it 1/2? It's 1/2 because it's a rectangle. It's a rectangle where half of it is missing. And how do you find the area of a rectangle? Area of a rectangle is, area of the rectangle would have been 7 times 5. 7 times 5. And therefore, the area of the triangle, area of this particular triangle, would be half of that. Would be half of it. Because the other half is missing. That's why it's 1/2 base times height. Which is what we did here. 1/2 base times height, 1/2 base times height. In other words, the area of the parallelogram is simply base times height. Number 39. Just give me a break, my throat is hurting. The hot cup of tea helps. Number 39. Question is, how much is 1.5 times 10 raised to negative 5 times 100? Let's see what the question actually says. Well, you can read the question yourself. It's a very long question, but that's what it boils down to. What they're asking us is, how much is this quantity? Essentially, what they want to see here is whether or not we know our exponents. They just want to see if you can manipulate your exponents. Well, how do we write 100 in terms of exponents? Exponent of 10. 100 can be written as 10 raised to 2. And here we have 10 raised to negative 5. Forget about this 1.5 for the time being. Here we have 10 and here we have the 10. So what we have when we have two quantities with the same base, we add their exponents. So this is simply 10 raised to negative 5 plus a 2 times 1.5, which is 1.5 times 10 raised to negative 5, and a positive 2 is going to give us negative 3. And there is your answer. There is our answer, which is whatever that answer happens to be, which is answer choice D. That's all. So what's going on here is that this is the normal level, they call it. This is the normal level. And today they're saying, I think they're dealing with pollution, some kind of pollution here. Water supplies. The normal amount of lead, that's right, is a lead, my accent is giving me trouble, lead pollutant. The normal amount of lead in the water is apparently this much. Today, it is 100 times the level. It is 100 times the normal level. Well, 100 times the normal level is this amount right here. 1.5 times 10 raised to negative 3. That's all. Which is same as 1.5 over 1000. But they're not looking for that. Let's go to the next one. Number 40. Number 40. It says a certain perfect square has exactly 4 digits. Alright, let's make a note of it. Certain perfect square. Certain perfect square has exactly 4 digits. Question is, how many digits in its positive roots? Do we understand the question? And this part, positive root that I just underlined here, we'll just find out at the end. We'll just find out in a little bit. That actually plays no role. Whether we're dealing with positive root or a negative root, the number of digits are going to be the same. Number of digits are going to be the same. For example, here's a perfect square. 81 is a perfect square. Why is 81 a perfect square? Because 81 can be written as positive 5 squared, or it can be written as, did I say positive 5? I mean positive 9. Positive 9 squared, or it can be written as negative 9 squared. This is called the positive root and this is called the negative root. So had they said certain perfect square has exactly 2 digits, this is a perfect square, it has 2 digits, not 4. It has 2 digits. How many digits does the positive root have? In this case, it's just 1. Obviously, you're not going to have a 2-digit number. If a 2-digit number, if you squared it, any 2-digit number when you square it, it's got to be more than 100. It can't be 81. But we're dealing with a 4-digit number, not a 2-digit number. We're told that a perfect square has a 4-digit. Let's see what we can do. So the first thing we have to do is find out the smallest 2-digit number, which when multiplied by itself gives us a 4-digit answer. It gives us a 4-digit answer. For this particular problem, you have to know your squares. Know your squares. I would like you to watch this particular video. I'm going to put down the tag for this particular video. I want you to watch it. Teas as in the tea that you drink. Don't worry about what it is. Just teas. Math day 2 and teas math day 3. Either type in this tag with my name, put down Keshwani and type in know your squares, or type in Keshwani and then teas, T-E-A-S, teas math day 2 and then teas math day 3. I would like you to watch both of these videos. You must know your squares. You must know your squares 1 through 20, and that's what's going to come in handy here. That's what's going to come in handy here. We know, if we know our squares 1 through 20, we know that 20 squared is 20 times 20, which is 20 times 20, which is 2 times 2, which is 4, and then 0 and a 0, which is 400. But that's too small. That is way too small. We are told that we have a perfect square which has 4 digits. This one is only 3 digits. It's only 400. It's not even close to 1000. We have to have at least 1000. Let's try 30, shall we? Let's try 30. 30 squared is 30 times 30. Again, 3 times 3 is 9, and then we have a 0 and a 0. 0 and a 0. Well, that's 900. We're getting very close to 4 digits, but still it's only 3 digits. It's 900. We need to get to 1000. It says certain perfect square has exactly 4 digits. Let's try 31, shall we? Let's try 31. 31 times 31. 1 times 31 is just going to be 31. and 3 times 1 is 3, and 3 times 3 is 9. You get 1, a 6, and a 9. That's too small. That's still too small. We need 4 digits. Certain perfect square has exactly 4 digits. Exactly 4 digits. Not at least. Exactly 4 digits. This is 961 is a perfect square. 961 is a perfect square because we just saw it is equal to 31 times 31. It is equal to 31 squared. It is a perfect square, but it only has 3 digits. We need 4 digits. Let's try 32. 2 times 2 is 4. 3 times 2 is 6. 3 times 2 is 6. And 3 times 3 is 9. Now we're going to get our 4 digits because 6 plus 2 is going to be 12. We're going to carry 1. So 4, 12, carry 1 becomes, there you go. Now this one has a 4 digits. It's a perfect square. It is a perfect square of 32. That's the smallest. 32 should do it. 32 should do it. 32 squared is a 4 digit thing. Question is, what's the largest one? Is this the largest one? Is this the only answer? I'm curious. What's the largest number that we can think of? What's the largest 2-digit number that you can think of whose perfect square is going to be a 4-digit number? Well, the largest number that I can think of, the largest 2-digit number that I can think of is 99. Let's find out what 99 times 99 is. Shall we? Do you know what 100 times 100 is? Well, 100 times 100 is very simple. 100 times 100 is just going to be 1 times 1 is 1. And then we have 2 zeros and 2 zeros. 1, 2, 3, 4. As you can see, this is a 5-digit number. That's a 5-digit number. To say nothing of the fact that this is 100, it's a 3-digit number. We're looking for the largest 2-digit number. The largest 2-digit number that I can think of is 99. Let's find out what 99 is. Now, the fact that this is exactly 10,000, listen very carefully, the fact that this is exactly 10,000 tells us that we don't actually have to do it out. 99 times 99, whatever the hell it is, it's going to be less than 10,000. But if it is less than 10,000, then it's going to be a 4-digit number. It's going to be 9,000 something. It's going to be a 4-digit number. Let's find out, shall we? Of course, in a real exam, we wouldn't do all of this thing. We just have to realize the question was very simple. The question was, a certain perfect square has exactly 4 digits. We just found a perfect square. This is a perfect square. It is exactly 4 digits. How many digits in the positive roots? Well, its root is 30. The root of this guy is 32. Positive 32 and negative 32. How many digits in a 32? 32 has 2 digits. How many digits in its positive roots? Which is same as saying, how many digits in 32? And the answer, of course, is 2 digits. 32 has 2 digits. So all of this work that we're doing here actually is only for learning purposes. This is not something obviously we have to do in the exam. Do you understand? A lot of the things we do in these videos which are extra material just for learning purposes. Just for learning purposes. So 99 times 99, 9 times 9 is 81. 8, or 1 carry 8. 9 times 9 again is 81. 81 plus 8 is going to be 89. And we're going to have the same number again. 1, 9, 8. So it's 1, 0. 10 plus 8 is 18. 1. You see? 9,801 equals 99 squared. So it doesn't matter whether it is 99 squared or whether it is 32 squared, whether it's 99 squared or whether it's 32 squared. 32 is the smallest number that we can think of whose perfect square will have 4 digits. 99 is the largest number that we can think of whose perfect square has 4 digits. But the point remains that in both of these cases, whether the perfect square that we're talking about is 1024 or 9801, in both cases their roots have 2 digits. 32 has 2 digits, 99 has 2 digits. How many digits in its roots? The answer is 2. Its roots is going to have 2 digits if the perfect square has 4 digits. Let's move on then. The very last one on the page number 41. In number 41, we are simply asked to find 1/2 x minus y squared. But the very first thing we have to realize here, listen, before we do any work at all, the very first thing we have to realize is that because of the fact that this whole quantity is being squared, the correct answer, whatever it is, listen very carefully, the correct answer, whatever it is, must contain the square of this first term, and it must contain the square of this guy. The square of this guy is 1/2 squared. 1/2 times 1/2 is 1/4. 1/4 x squared and y squared. This is not all of the answer, but it must contain these two terms. The correct answer, whatever it is, must contain these two terms. If you find any answer choice that doesn't have 1/4 x squared, or something that doesn't have y squared, is not the right answer. Let's see what we can do. Are there any such answers? Oh, there you go. D and E are not there. Neither is C. Oh, what do you know? A, B, C, D, and E. C is not the right answer because it has 1/2 x squared. It has 1/2 x squared. It's wrong. It has to have 1/4 x squared because 1/2 times 1/2 is 1/4. 1/4 squared because we have 1/2 squared. D is not the right answer because D doesn't have 1/4 x squared. It only has x squared. And similarly with E. The answer is either A or B. The answer is either A or B. Now the question is, what is the difference between answer A and B? What is the difference between answer choice A and B? A says 1/4 x squared plus y squared, and of course B says whatever it is. What is wrong with A? What is wrong with A is that A is missing the midterm. A is missing the midterm. That's all we have to realize. That A is missing the midterm, and therefore the answer is B. We don't have to do any work here. We don't have to figure out what this is. We don't have to waste our time trying to figure it out. We just have to realize two things. First thing we have to realize is that the correct answer, whatever it is, must contain 1/4 x squared. Must contain 1/4 x squared. Right away we can cross out C, D, and E. We must also realize that the correct answer, whatever it is, must contain the midterm. And I'm going to explain to you in a second what that means. Let's understand this concept. Let's understand the concept of midterm by using numbers instead of variable, instead of doing the algebra problem. Let's do an arithmetic problem to understand the concept of midterm, shall we? For example, how much is 5 minus 4 squared? 5 minus 4 squared. Well, according to answer choice A says it is the square of the first quantity. Or right here, it's the square of the first quantity plus the square of the second quantity. In answer choice A, we have 1/2 x squared plus y squared. If you use that logic, answer choice A says is the square of the first quantity plus the square of the second quantity. Well, let's find out, shall we? Let's find out what's going on here. The square of the first quantity, in this case, will be 5 squared. 5 squared plus the square of the second quantity, which is 4 squared. But of course, we already know what the answer is. 5 minus 4 is how much? 5 minus 4 is 1. 5 minus 4 is 1. And 1 squared is just 1. This is not going to give us 1. This is going to give us 25 plus 16. 25 plus 16 obviously does not equal 1. What's the problem? The problem is that we are missing the midterm. Let's find out the missing midterm in this case, shall we? Let's find out. 5 minus 4 squared is same as 5 minus 4 times 5 minus 4, isn't it? Which gives us 5 times 5, which is our 5 squared, which was this guy right here, 1/2 x squared. Then we're going to have 5 times negative 4. 5 times negative 4. Then we're going to have negative 4 times 5. negative 4 times 5. You see, negative 4 times 5. And then we're going to have negative 4 times negative 4. Negative 4 times negative 4 is negative 4 squared. So this is where we get our 5 squared and a 4 squared. 5 squared plus 4 squared. You see, 5 squared plus a 4 squared. But we are missing in the middle. What we are missing here is, this is our, think of this as A minus B. Think of 5 as A and think of B as 4. So here we have A squared plus A times B plus A times B plus B squared. Except here, our B is a negative quantity. Our B is a negative quantity. So here we have a 5 times negative 4, which is negative 20, and 5 times negative 4, which is another negative 20, so we have negative 40. So we get A squared plus 2 times AB, and AB gives us 2 times AB. 2 times AB plus B squared. And that 2 times AB is the missing part. That 2 times AB is the missing part, which is, okay, watch, I'm going to put it now. 5 squared plus 2 times 5 times negative 4 plus negative 4 squared. Now this will give us the correct answer. We know the correct answer. The correct answer is 1. The correct answer is 5 minus 4 is 1. 1 squared is 1. Let's see what this gives us, shall we? Let's finish it up. So here we get 25 minus 2 times 5 is 10. 10 times 4 is 40. Negative 40. And a positive 16. Now what do you suppose we will get when we add up 25, negative 40 and positive 16? 25 plus 16, believe it or not, 25 plus 16 is 41. 41 minus a 40 is your 1. What we were missing here is this midterm, the negative 2AB part. The negative 2AB part, which is why the correct answer is B. We don't have to look at what B is. It doesn't matter what B says. It makes no difference. In the real exam, we wouldn't waste our time looking at B. You simply have to realize, again, one more time, okay? Had it been the real exam, listen one more time very carefully. There is a difference between doing this problem for learning purposes and doing this problem in the real exam. Those are two entirely different worlds. When you're solving this problem for practice at home, do them for learning purposes so that you learn the material. You have to learn the material first before you can look for the shortcuts. It's difficult to look for shortcuts if you don't understand the material to begin with. So one more time, had it been a real exam, so now we're going to do the same problem from the very beginning, pretending that's a real exam, okay? We're going to do the same problem one more time, had it been a real exam, and watch what happens. A, B, C, D, and E. Okay, are you ready? Time yourself, see how long it takes. It should take no more than a few seconds. This is what they want you to find. Immediately we should say to ourselves that the correct answer, whatever it is, must contain 1/4 x squared. 1/4 x squared. C, D, and E do not have 1/4 x squared. A doesn't have a midterm. A doesn't have a midterm in it. A midterm is missing. The answer is B. That's it. That midterm was this 5, negative 40. That guy was missing. What we had was 25 and a 16, but we didn't have negative 40, and without the negative 40, we'll end up saying that 5 minus 4 squared equals 25 plus 16. 5 minus 4 squared does not equal 41. 5 minus 4 squared equals 1. And therefore, in order to get 1, we need the 40, the missing 40, the negative 40. That's the midterm. That's what's missing in B. Therefore, the answer is B. I'm not going to waste my time doing it out what it is. It doesn't matter what it is. Whatever it is, it's got to be the answer. That's the only one left. That's the only answer choice left. C, D, and E are absolute nonsense. C, D, and E are absolute nonsense because they don't have 1/4 x squared. A doesn't work. It does have the right first term. It does have the correct last term, but it's missing the midterm. The answer is B. I'll see you tomorrow, okay? Bye now.